Hey everyone, Geophysicist Stefan Burns here. Happy Thanksgiving, or should I say even happy QUAKESGIVING. We just had a magnitude 6 earthquake strike just outside of Anchorage in Alaska today on Thanksgiving. This is the day that we celebrate it in the United States at least. And this is a big earthquake. And there's about a 5% chance that in fact this is a foreshock to something larger. That's in general the statistic as it relates to earthquakes. About 5% of the time you get a big quake. In fact, it's a quake leading up to something bigger. So not a huge risk, but an elevated risk for there being an even bigger shaker near a large population center, which is Anchorage. 300,000 people there early morning, a lot of them woken up by the shaking from that magnitude 6 on Thanksgiving. But it's not the only earthquake that we've had today. In fact, just about 12 hours before that, we had a magnitude 6.6 earthquake strike Indonesia, this island here, Sinabang, and that is a big earthquake, a magnitude 6.6. And in fact, this is something that we've been forecasting to occur based off of these space weather conditions. Now, if you're new to the channel, hello and welcome. I'm your host, Stefan Burns, geologist, geophysicist, space weather guy, cosmic bro, just someone interested in what's happening here energetically on Earth. So we look at all the different factors because they're all connected together. That's how the universe operates. So we look at earthquakes, volcanic activity, geomagnetic storms, weather events. Also, we zoom out, we look at the sun, solar activity, space weather, planetary resonances and alignments, cosmic forces and more. I bring all that together, present videos almost daily. So if you like the sound of that, then please subscribe. Well, there has been some notable space weather over the past few days that is linked to increases in global seismic energy release. And so I put out a forecast back on the 24th of November that we would likely see more magnitude 6 plus earthquakes in the days ahead and potentially even magnitude 7 plus quakes. And now we've had 2 magnitude 6 plus quakes in the past 12 hours. And this is notable because we hadn't had any for more than 2 weeks. So we were in a magnitude 6 earthquake drought, and then all of a sudden, boom, we get 2 of them back to back with the appropriate space weather conditions that we were looking at on the same day and on Thanksgiving of all days. So we track global seismicity here, and we look at the sun as one tool to help us understand what could occur. Here are those space weather conditions. So we have a coronal hole here, and what this is we're looking at the Earth facing side of the sun. It takes about 28 days for the sun to rotate in the equator and a little bit longer up in the polar regions. And we're looking at the corona. So the corona is the outermost atmosphere of the sun, made up of very high temperature, highly vibrational plasma. So this is millions of degrees Kelvin, whereas the actual surface of the sun is like 10,000 Kelvin. It's quite a bit cooler temperature on the surface, but the corona is very, very hot. And sometimes you get these gaps in the corona. So you just won't have plasma there. And so with this view of the sun, 211 angstrom, and they color it this purple, it shows up as black, as deficient, low density, because there really isn't much plasma there. And that's because the magnetic field of the sun is extending out into space. And right now we're in solar maximum. So the magnetic field of the sun is already pretty perturbed, all chaotic and twisted up because it's undergoing a magnetic flip. Back in 2019, 2020, we were in solar minimum, had a clear polarity. During solar max, 2024, 25, 26, it's going to be more chaotic and just all over the place. And then going into 2030s, early 2030s, we'll have another solar minimum and a clear magnetic field polarity. So we have this magnetic field extending out of the sun deep into space. It actually connects to Earth. That pulls all the plasma in that part of the corona and pushes it out, creating what's known as a high-speed stream. So high velocity solar wind that will then hit the Earth, specifically if this coronal hole cuts through the equator of the sun, which we get this trans-equatorial portion here. This is a big coronal hole. You don't see them this big that often, though we have been seeing them like that for this solar maximum, which is a little anomalous, but not impossible. It's still a little anomalous. That's a big trans-equatorial portion, making it guaranteed that we were going to get hit by that. We've been hit by that for the past few days. There's been elevated geomagnetic activity. The solar wind density dropped. That's the key factor that we look at. That's what helped me put out my forecast back on the 24th of November. And well, we had now 2 magnitude 6 plus earthquakes. Here we can see that forecast. I just want to show you, right? The proof is in the pudding. So 3 days ago, this was November 24th, geomagnetic activity is now at active conditions, KP4 plus, from the sudden impact of fast solar wind, approximately 700 kilometers per second from a very large chain of coronal holes on the sun, including a sizable trans-equatorial one. Earthquake watch now in effect. Expect some magnitude 6 plus earthquakes, if not even magnitude 7 plus. And well, that's exactly what has happened today. We have our latest quakes here provided by the USGS, and we see this magnitude 6 earthquake just occurred there, depth of about 70 kilometers. And we can punch in on that. There have been some aftershocks, but nothing big. So typically for an aftershock, it'll be 1 magnitude less than the main shock. There'll be like 1 or 2 of those perhaps. If there's more than 1 big aftershock, the magnitude of them collectively will be a little bit lower. Like maybe it'll be a whole bunch of 4.5s instead of a 1 single magnitude 5. But this just occurred. We only have this 3.2 there. And I think there was a little foreshock here, yeah, just a couple minutes before a magnitude 3. So we haven't had a clear aftershock from this earthquake yet, and that is very possible. So we'll have to wait and see. We'll just have to kind of watch, but we see Anchorage right there, very close by. And then if we zoom out and go largest magnitude earthquakes first, we see that 6.6 there also, Indonesia. So this is the past day, just the past 24 hours. And really, if you look at the time for these, right, you see that this all occurred just in the past 13, 14 hours right there. If we go and check out our earthquakes for the past 30 days, you'll see this deficit of magnitude 6 earthquakes that I was talking about. So here we have it set for largest magnitude, and we see that this is the 9th of November. We had this 6.8. We also had a 6.4 Japan, same day. So those are both in Japan. Here's our 6.6 Indonesia that occurred today. Here is a 6.2 earthquake that occurred on the 2nd of November. That was in Afghanistan. And we can look here. We see a 6.1 in Russia on the 3rd of November, and then a 6.0 on the 4th of November. Here we see a 6.0 on the 10th of November, and then there is our Alaska quake, and there's no magnitude 6s below that. So we have the 10th of November right there. That's the most recent earthquake to these 2 that occurred today. So it's been 17 days, effectively, since we've had magnitude 6 earthquakes. Earthquake activity has been very, very low for the past 2 weeks up until the present moment. We see that with our global seismic activity level. We see that we've been having fairly frequent bursts of seismic energy release, sometimes going up to extreme levels with high magnitude 7 plus earthquakes. This is that 6.8, 6.4 double sequence in Japan. Afterwards, we cooled off and we only had moderate to low activity. Now we're finally back up. So coincidentally, you could say, we have almost no magnitude 6 plus earthquakes, and then right after that high-speed stream impact, boom, we get 2 of them back to back, and that was forecast, and we forecasted a lot of earthquakes accurately, and just in terms of a global sense on this channel. The mega quake that occurred in Russia, July 29th, 2025, 8.8 magnitude. We forecasted that 3 days in advance of it being a potential thing, and it happened. So that was a pretty slam dunk thing, and that's the biggest earthquake that we've had since 2011. So this is the intensity map for the magnitude 6 in Alaska, and the do you feel it responses weren't really crazy. So some people felt it moderately. We see the intensity there. Some people felt it a little less intense than that. Thankfully, it was further away. If that had been directly under Anchorage, it would have been pretty intense. Here we see the population density for this area. So quite a lot of population up there. Of course, we get even denser population with Anchorage itself. So a lot of residents in this area of Alaska woke up to this magnitude 6 earthquake because it's pretty early for them. And you go here. we can see those do you feel it responses directly from the USGS. So it looks like people to the west of this felt it a little bit more strongly than people to the east. But in general, this was felt fairly moderately. Some people even kind of felt it a little strongly, but magnitude 6 earthquake, 5% chance of that being a foreshock. We hope that's not the case, but it's good to track this. In general, with foreshocks, they're usually 1 magnitude less, though they can be bigger than that. Depends on the severity of the quake. So there's about 5% chance that we're seeing a magnitude 6.8, magnitude 7, something like that from this area in the immediate future. I wouldn't bet the house on it, but it's definitely possible. So if you're from Alaska watching this right now, you're watching on replay, whatever, you should definitely make sure you have some plans in place for the next couple of days as it relates to this. Let's look at our real-time solar wind so you can see what I'm talking about as it relates to the space weather forecasting. Here we have effectively the properties of the solar wind plasma flowing by the Earth. In fact, this is measured 1% of the distance from the sun to the Earth at the L1 Lagrange point. So we have our interplanetary magnetic field up here. We have our solar wind density, our velocity, our temperature, and our measure of geomagnetic volatility. You see that we were low with the volatility, and then we ramped up into a G1 storm. And we've been in active conditions effectively since. We actually just had another little bump up here to a G1 minus storm just in the past 9 hours. So we did hit a KP index of 5 right there, but this has basically been elevated conditions because the solar wind velocity has been elevated. So we were down at like 450 or so, ramped straight up to close to 700. We see that right there, 700 kilometers per second. Here we have some data dropouts. Don't worry about that. And then we even went higher, going up to nearly 800 kilometers per second. We've started to go down, as you see, but we're still over 600 kilometers per second. That's quite elevated. And then if you look here, look at how the density of the solar wind, this is 5, 6 particles per cubic centimeter. Look at how that dropped as the velocity goes up. That's classic with these high-speed stream impacts because it's moving faster, it's lower density, and the temperature also ramps up as you see. So we track the solar wind density really as something that's connected to these earthquakes because it really seems, if you look at the historic record with the biggest earthquakes that we have on record, they almost always happen when the solar wind density gets extremely low, like even anomalously low at 0.1 particles per cubic centimeter or lower. That's the lower limit that this thing can measure. So we don't know how low it goes actually beyond that. If it hits that bottom level. So you see that we were in this 1 zone, even going below 1 at times, never really going above 2. We're still there right now. So when we're close to that 1 particle per cubic centimeter, that seems to be connected to increases in seismicity after these trans-equatorial coronal hole high-speed stream impacts. I know it's a whole mouthful. If you watch the channel consistently, you'll learn this over time through osmosis. Because I focus on education here as well as giving you the rundown as to what's occurring. So this is why I put out that forecast back on the 24th of November, and then, well, lo and behold, 2 magnitude 6 plus earthquakes in less than 14 hours today on Thanksgiving. Happy Thanksgiving, everybody. We can look maybe and find some videos from X. I mean, this earthquake just occurred. It is Thanksgiving. People are doing stuff. It was very early in the morning. I haven't seen any real good videos from this earthquake yet. The shaking wasn't too crazy, or some of the rooms that I saw one video and the room was like a hoarder's house. So interested in showing that on the channel. This one doesn't really show too much shaking. There's a little bit, but nothing for us to go, oh my God. But if you type this in, if you just type in Alaska earthquake on Twitter and then click latest and watch this over the next few hours, day or so, you've seen footage from that. I haven't seen anything really yet from it, but that is a resource that you can check out. And let's hope that this has updated now. It has not. We get a earthquake visualization from this website. I will post this to my Twitter X once it's live because they have their visualization set. I can show you the one for 6.6 right here. They have their visualization set for Alaska. So it's going to be really interesting to see this visualization that has the epicenter right here, then spread out all across Alaska, because this is coming in from Indonesia. These visualizations always show the North American seismic network. So I'll post this also to my Twitter X once it's available, but this quake just occurred, so we don't have that visual on it yet. But if we just kind of zoom out and talk about what's happening right now, we are still in the effect of this coronal hole high-speed stream. Solar wind density is still around 1. And we, in fact, if we watch this video, you'll see another coronal hole rotating into view near the end that's also trans-equatorial. That's about the same size as this one. We see it start to form right there. We don't know what's going to happen to that as it makes its transit towards geoeffective, which is right about here. But that is likely to impact us in the probably about 9 or 10 days or so. So that could be another earthquake generating influence. At least it's something that doesn't help earthquake activity. If you track this across time, you can see the trend that it definitely does not help earthquake activity being reduced. It seems to really generate the higher magnitude earthquakes, which are responsible for the majority of seismic energy release on the planet. Because every magnitude that you go up, you increase the energy output from that by 32 times. So a magnitude 6 earthquake is 32 times more energy than a magnitude 5, meaning you need 32 magnitude 5 earthquakes equal 1 magnitude 6. You need 32 magnitude 6 earthquakes to equal 1 magnitude 7. So when you track the highest magnitude earthquakes, they are almost always with these coronal hole high-speed stream impacts lined up. And that's where you get the vast majority of seismic energy release. So the trend is basically undeniable. So this is coming up afterwards, which is going to be interesting, but we are still in the effects of it right now. So we had this magnitude 6.6 here. We have this magnitude 6 that just struck Alaska, giving everybody there a quakesgiving. And we'll see what comes next. We could have more magnitude 6s, magnitude 7 even, in the days ahead. At least as of right now, we've had 2 now. So it's certainly possible that we get more. At this point, it's hard to assign like a probability to that, but we're still in the effects of that. So just something to be aware of. We track this globally. It's hard to predict exactly where you're going to get activity in the magnitude unless you have a lot of like prior ongoing earthquake swarming kind of like activity that's indicating something's going to occur. There really hasn't been too much indicative activity that something with like this magnitude 6 is going to occur here. Though there has been some earthquake activity kind of across Alaska, but it generally does. That's the thing. So it's important to keep that in mind. Let's look at the historic earthquakes here. And yeah, so we want to set this. That's the new one right here. Let's go to our catalog view here. And let's set this for custom magnitude 6. And we'll go back to the year 2000. Let's do the year 2000 and see what sort of magnitude 6 earthquakes have struck Alaska for the past 25 years. Because this will be interesting. It gives us a sense of just how active seismically Alaska is. So we'll go here and we'll click it like that. So here are all the magnitude 6 earthquakes that have occurred in Alaska for that zone that I chose since January 1st of the year 2000. So a lot of magnitude 6 plus earthquakes. We see that the highest magnitude being an 8.2 in 2021, but that was down here where there's not as many people. Most of the earthquakes are along that subduction zone or along the subduction zone off the coast of Canada, which is in Alaska. Now you're talking about, you know, what is it called? Just the island there. What is that island called? Vancouver Island and more. So if we go up here, we see that there's not too many big earthquakes that occur in this region. Specifically, zoom in even more. This magnitude 7.1 struck Anchorage. Let me move that for you. This magnitude 7.1 struck Anchorage in 2018. That was also November 30th right there. So that's kind of interesting. little bit of a synchronicity that this one strikes on the 27th of November, that one strikes on the 30th of November, close together. This one bigger and closer. So I'm sure the residents of Anchorage really remember that earthquake, and hopefully this is not a foreshock to something like that. So that is what's happening right now energetically with the Earth. We are still in the influence of that coronal hole high-speed stream. We just had 2 magnitude 6+ earthquakes. We've had a bunch of volcanic eruptions. If you're new to that story, check out my channel. Watch my recent video on that. We have had some historic volcanic eruptions recently. So that is very interesting, ongoing right now, especially the Haley Gubi eruption in Ethiopia, Africa. First time that volcano has erupted in more than 10,000 years. So thank you all so much for watching. Happy Thanksgiving. I've been your host, Stefan Burns. I'm wishing each and every single one of you well. Please take care of yourselves. Have a great time with friends and family. And remember, Thanksgiving is about giving thanks. So it's really about reflecting on what you're thankful for in your life, how others have helped you, how you can help others, right? This is a time to be mindful of that, and also to give thanks to the land, right? Thanksgiving for the Native Americans was about, giving thanks to the community and their tribe, but also the bounty of the land. So let's not forget that we are here and we're able to enjoy, our community, civilization, society, and all these modern gifts, you could say, because the land provides that for us. So sometimes the land decides to do a big shake to kind of remind us that it's a very powerful force to be reckoned with and to be respected. And we are very thankful for all the bounty and gifts of Mother Earth. So thank you all so much. I'll see you all very soon in the next video. Happy Thanksgiving.